Hi, I'm Kate, and on this episode of Bite Scized, we're going to be exploring what a mole is, molar mass, and other foundational chemistry topics through Paneer. So we found that adding calcium chloride is the key to getting perfect texture for paneer, and we were curious to know if we could substitute magnesium chloride for calcium chloride and get the same results. So we first started with an experiment where we did 3 different trials of paneer, one with calcium chloride, one with magnesium chloride, and one with neither substance. To see our results, analyze them for yourself, and get the most out of this video, be sure to check out our full lesson at bitescized.org. The basic gist was that magnesium chloride was pretty effective, but not quite as effective as calcium chloride. So why might that be? Well, let's think about why calcium chloride was effective in the first place. It's all about adding in calcium ions, which can help form calcium phosphate bridges within the casein network. Within this, we're operating under a couple of assumptions. First, we're assuming that when we add magnesium chloride, that it behaves pretty similarly to calcium chloride, and that it's essentially adding magnesium ions, which are going to behave similarly to calcium ions. The second assumption, which is what we're going to focus on today, is that we're assuming that when we add an equal mass of magnesium chloride and calcium chloride, we're adding in the same number of molecules or ions or atoms, basically the same amount of stuff. But that's actually not the case. An equal mass of calcium chloride and magnesium chloride does not equate to an equal number of molecules. In order to understand why, we have to look more carefully at magnesium and calcium and use the periodic table. Here we can see their relative atomic mass and see that calcium atoms have more mass than magnesium atoms. And this makes sense when we look at their atomic structure. We can see that calcium has more protons and neutrons, which would result in more mass. Keep in mind, we're simplifying this a little bit here and are not going into things like isotopes. The big takeaway is that even though we added the same amount of mass of each substance, we didn't add an equal number of molecules because those substances are made up of different atoms and those atoms have different masses. So can we actually calculate the number of molecules that we added? Short answer, yes. Long answer, that's what we're going to go through right now. And it's all about some conversions of grams to number of molecules or number of particles. So a mole is a specific number, similar to how a pear means 2, or a dozen eggs is 12 eggs, or a ream of paper is 500 sheets of paper. Okay, chances are you probably didn't know that one, but you get the picture. We can use the mole to describe the number of particles in a substance. However, unlike eggs, atoms are really small. A single grain of salt can contain trillions of atoms. So because of this number is huge. 1 mole is equal to 6.02 times 10 to the 23rd particles. So if we have 1 mole of copper, we have 6.02 times 10 to the 23 copper atoms. If we have 1 mole of salt, we have 6.02 times 10 to the 23 salt molecules. And if we have 1 mole of chocolate chips, we have 6.02 times 10 to the 23 chocolate chips, which is an absolutely absurd number and is more than enough to fill the entire Earth with chocolate chips. This insanely large number is also referred to as Avogadro's number. And while that big of a number is pretty impractical when it comes to counting something like chocolate chips, it's actually really useful in chemistry when we're trying to quantify substances, like for chemical reactions. So the mass values we see on the periodic table tell us how many grams are in 1 mole of each element. Another way to look at this is that if we had 24 grams of pure magnesium, we'd have 1 mole of magnesium, whereas we'd need 40 grams of calcium to have the same number of calcium atoms. Based on this, what is the mass of 1 mole of chlorine? Now, to figure out the mass of 1 mole of a compound with multiple elements, like calcium chloride, we simply add the mass of each atom involved. So for calcium chloride, we add the mass of 1 calcium atom and 2 chlorine atoms, and we get 111 grams. So that means that 1 mole of calcium chloride has a mass of 111 grams. Pause here and try it yourself with magnesium chloride. Let's connect this back to our example. So we said that we had 0.5 grams of calcium chloride and magnesium chloride. Just to make things simple, we're going to say that we have 1 gram of each, so the math is a little bit easier. Our end goal is to calculate how many calcium and magnesium ions we added if we added 1 gram of each substance. So let's start off with calcium chloride. Now we just figured out that 1 mole of calcium chloride, or 6.02 times 10 to the 23rd calcium molecules, has a mass of 111 grams. And we have 1 gram, so a lot less. So we're going to take our amount in grams, convert that to moles, and then convert that to number of molecules. So first, we're going to convert from grams to moles. So we take 1 gram and we divide that by the molar mass, which is 111 grams. We then take that value and convert it from moles to number of molecules by using Avogadro's number. Our final answer is that we have 5.43 times 10 to the 21st calcium chloride molecules, and we know that we have 1 calcium ion per calcium chloride molecule. Try it for yourself using the same setup with magnesium chloride, and then check your work when done. After doing these calculations, we can see that we have a lot more magnesium chloride molecules than calcium chloride molecules, and so we have a lot more magnesium ions than calcium ions, and that might be a reason why we're seeing some differences. So let's think about how we could set up a second experiment where instead of adding an equal amount of mass of magnesium chloride to calcium chloride, we actually add an equal number of moles. So we're going to leave you on a bit of a cliffhanger where you have to figure this out for yourself, but be sure to check out our lesson to see our final answer and work, as well as the second experiment, because we did actually try it out. Thanks for tuning in on this episode of Bite Scized. We hope that this helped you understand what a mole is and why it might matter. Be sure to like and subscribe for more videos.